Welcome to this presentation. I'm Emanuele Cannella, ESR number 12 from the MICROMAN project. I'm going to present my project titled High Precision Tooling for Electrical Sintering of Titanium and Permanent Magnets. This is the agenda of the presentation, where I'm going to talk about the motivation of the project, the evolved technology, namely sintering, and the case studies which were analyzed in the project. Finally, I will give my conclusions to the project. What was the real motivation? To meet the industrial needs, the continuous improvements in terms of cost savings, which is done from the reduction of the time required and decrease the material waste which comes from conventional manufacturing processes. Furthermore, the less process time for high temperature process, the less is the influence from the process, for example oxidation and reaction, which are favored by high temperatures. Sintering processes are widely exploited in industries because of their near-net shape capabilities. The powder is compacted to the desired shape, and then the density is increased due to the atomic diffusion phenomena, which occur while the green body is kept in a temperature-controlled oven. Why electricity? By applying electricity, it is possible to use the gel heat produced when the current is flowing. This principle can be applied either to the die, to the sample, or both simultaneously. The electrical current makes possible high heating rates, which the thermal transfer only cannot reach. Resistance sintering focuses the electricity only throughout the powder. It does not work for electrically insulating powder. The pressure is kept to maintain a favorable electrical resistance and avoid electric arcs, which may destroy the tools and the sample. Four phases can be distinguished: A, B, C, and D. Heating rates are very high and depending on the amount of electrical current which is given. Due to the similarity with the resistance welding approach, a resistance welding machine is used and adapted with proper tools. In this case, the tool designed to sinter disc is described. And here is the ring tools. A typical process profile is hereby represented. Three main process parameters can be indicated, namely the electrical current density, the sintering time, and compaction pressure. To be, to be noticed how the compaction pressure is kept during the whole sintering process. For experimental purposes, titanium was firstly sintered to investigate the feasibility of the process. Both disks and rings were successfully sintered. Process parameters range are described and final properties resulted comparable with bulk ones. The main microstructures were deeply investigated. Two representative ones are shown, giving an overview on how process parameters deeply influence the results. Clear bonded particles are seen for low currents, therefore indicating that the melting temperature was not achieved. High current led to fully bonded structure, where melting possibly occurred at some points.